Hello students, so again I am here with the next part of my video, that is video number part 12. So in our previous class we have discussed many preparation reactions of amines. So the rest of the reactions will be discussed here today. Okay. So the first type of reaction I am going to start today, that is Gabriel Thalamite synthesis. Okay, Gabriel Thalamite synthesis of amines. So let's come to the board that how we could synthesize the amine starting from a thalamite. Okay, so what is the formula of thalamite? It is coming from the structure of thalic acid. Thalic acid has the formula like this. This is the formula of thalic acid. So thalamite is the amine derivative of this amide. So there, this carboxylic acid, so there will be a NH group, okay, present between the two CO groups. So this is called thalamite. So next we have to add here a KOH solution or alkaline solution. Okay, alcoholic KOH solution we have to add here. So now what will happen, just see, this hydrogen will be removed out with this hydroxyl group as water. Okay, so this is K plus OH minus, and from here it is H plus and N minus. So this minus charge will combine with the K plus, and this H plus will combine with OH forming the water. So what will happen next? So there will be an addition of potassium in presence of hydrogen here. Okay, so this type of the potassium salt of thalamite we will get here. So next what we have to do? Next, in conversion type reaction normally we use this process. So if you want to add an alkyl, any alkyl group, if you want to add here, then you have to take the iodide salt of the alkyl group. Suppose I want to add here C2H5 or CH3. So then you have to take the iodide salt of C2H5, that is C2H5I ethyl iodide, or CH3I methyl iodide, that you have to take. Okay, I am taking here C2H5I ethyl iodide. Okay, so now what will happen? Again, this is now minus, this is plus, this is minus charge, okay, and this is the plus group. So potassium will be removed out with this iodide by forming potassium iodide. Now this C2H5 group, it will be added with the nitrogen forming this compound CO single bond N, and here there will be the addition of this alkyl group C2H5, okay, that is attached here with the nitrogen. So nitrogen single bond C2H5. So now again we have to do hydrolysis here for the formation of an amine. So hydrolysis in presence of a strong base like KOH or NaOH, okay, then you have to heat this compound. So what will happen? So there will be the breaking of this bond, okay, breaking of this bond, and during hydrolysis two hydrogens will be attached with the nitrogen. Okay, this bond will be broken out, two hydrogens will be attached with this nitrogen forming this compound C2H5 single bond nitrogen. Okay, two hydrogens will be attached here 2 hydrogens will come here, and here 2 OK groups. That means this one. Okay, COOK, COOK, okay, okay. So these two potassium oxide, these two groups will be attached here, because this was minus and this was plus. So nitrogen was minus, so minus, negatively charged nitrogen will accept the hydrogens from here, okay, 2 KOH, forming this amine C2H5 NH2 ethyl amine. That was our expected product, okay, and the other compound that will be formed from here is, okay, the potassium salt of phthalic acid, okay, potassium salt of phthalic acid will be obtained. So this is the product, and the same type of reaction we can carry also from this step by using hydrazine. What is the formula of hydrazine? NH2, NH2, okay, so we could use here hydrazine, NH2, NH2. So same type of reaction will take place where this nitrogen will be attached with 2 hydrogen from here, okay, from NH2, NH2, and there will be the addition of 1 hydrogen compound in between these 2 CO groups. So we will get a compound like this. Okay, this type of compound will form from here, and 2 hydrogens will be attached with the nitrogen of this compound, forming a ethyl amine. So from this step we could prepare the ethyl amine by hydrolysis or by using the hydrazine. So this is Gabriel's phthalimide synthesis. Okay, from phthalimide we could prepare the amines. Okay, now the next reaction, is that I have told in a very brief in our earlier class, that is Hofmann degradation, Hofmann bromamide degradation reaction. Hofmann's degradation reaction, where we could use any type of compound, like here I am starting here from an aromatic compound, okay. So this is benzamide, benzene with CONH2 group, okay, benzamide along with bromine plus KOH, bromine or chlorine in presence of a strong base like KOH, it will form. So this is called degradation reaction, because there will be the removal of this CO group and there will be the loss of 1 carbon atom from this amide, okay. So there we will get from benzamide we are getting aniline, okay, due to the removal of CO group. So another products that we will get from here are 2KBr plus K2CO3 plus H2O. Okay, so these compounds will be formed from Hofmann bromamide degradation reaction, where we could use this type of benzamide or an alkylamide like acetamide, where it reacts with bromine in presence of alkali, okay, forming an amine which is having 1 carbon less than the parent amide. Next one is Schmidt reaction. Number 3, Schmidt reaction. It is starting from a carboxylic acid, okay. Just like here I have taken acetic acid and it should be reacted with hydrazoic acid. It should be reacted with hydrazoic acid, that is having the formula HN3, not NH3. NH3 is ammonia, but HN3 is hydrazoic acid in presence of concentrated H2SO4. In presence of concentrated H2SO4, so what will be the products here? So from here we will get CH3 NH2 plus N2 plus CO2. So in this process also one CO2 group from here it will be removed out, okay, as carbon dioxide, and then there will be the addition of one nitrogen forming a methyl amine and nitrogen. So this is also one type of degradation reaction where we could get an amine starting from a carboxylic acid. So this is known as Schmid reaction. Now the next one, again here we could prepare the amines starting from any type of carboxylic acid, okay, sorry, not carboxylic acid, starting from aldehydes or ketones. So let's see. Next, number 4, I think. Okay, so here I am taking acetaldehyde, that is CH3CHO, acetaldehyde, okay. Now you have to add here NH3, that is ammonia. So now what will happen here? So first of all, the nitrogen, through its lone pair, it will make an attack on the positively charged carbon. The carbon is positively charged and the oxygen is negatively charged. So nitrogen will attack on the carbon, okay. So what we will get from here? CH3 single bond CH. So now whenever it is attacking on the carbon is making 5 bonds, which is not possible because the carbon is tetravalent. So this bond will go upon the oxygen as a negative charge, okay. So O minus. Now there will be the addition of NH3 forming a positive charge, because nitrogen here is making 4 bonds, so it is gaining a positive charge. Now one rearrangement will take place here. Rearrangement will take place from where we are getting this O minus, this negatively charged oxygen will take one hydrogen from NH3 and it will be NH2 and it will be OH, okay. Now one water molecule will be removed out from here as minus H2O, okay. By heating, one water molecule will be removed out from here, the OH from the carbon atom and the hydrogen from the NH2. So there will be a formation of double bond from here. So there we are getting this compound. This is known as imine compound, okay. This type of imine compound we are getting from here. Now if you add here hydrogen in presence of nickel or platinum or palladium, whatever you want to add, so it will be reduced to NH, CH3, CH2, NH2. There will be the addition of hydrogen with the CH and with the NH, okay. So there will be the formation of this group. So the same type of reaction we can carry along with this is the example of aldehyde. So we can carry the same type of reaction by using a ketone. So therefore this hydrogen, there will be a presence of alkyl group. So at the final step, there we will be getting a secondary amine. Here we are getting a primary amine. And if you do the same process by using a ketone, then you could see the formation of a secondary amine. Clear? Okay. So by this method, we could change or we could convert the aldehydes or the ketones into primary and secondary amines respectively. Okay. Now the next reaction. The next reaction is, now we could change the secondary amine. Okay, we could change the primary amine into secondary amine or the primary amine into tertiary amine. So we are starting from a primary amine. Suppose I am taking a primary amine, that is CH3 NH2, and I want to convert it into a secondary amine. That means one of the hydrogen of the nitrogen atom that has to be substituted by another alkyl group. So here I have to use one iodide salt of any alkyl group, that alkyl group which I want to add here. Suppose C2H5 I am adding here. Okay, CH3NH2 C2H5I. So what will happen here? One hydrogen will be removed out with this iodide as Hi, and it will make CH3NH C2H5. Okay, so this is the example of secondary amine. So from primary amine we can get secondary amine, and again from primary amine we could change the primary amine into secondary amines by using, okay, here we have to then take, suppose CH3I, okay, CH3I you have taken, and then react it with NH3 ammonia, and here 3 alkyl iodides are there. So mainly what will be the type of reaction? That will be a substitution reaction with the NH3. So 3 hydrogen atoms of NH3 will be substituted by 3 alkyl groups. Okay. So here initially there was the presence of hydrogens, but after this reaction these 3 will be substituted by 3 CH3 groups, and this iodine it will be removed out, okay, as Hi, 3Hi. So by creating the iodide, by creating the ammonia with excess of alkyl iodide, we could change it into this type of compound. Okay. So I think the time is over for today. So in our next class we will discuss about different types of properties of amines. Okay, chemical properties as well as physical properties. So I hope all of you have understood today's class. So we will meet in our next class. So till then, take care, stay safe. Thank you.